Hey everyone, so today is the ninth day of coding. The last day I went to IBA, and honestly, it was fun. I got new ideas, I coded, and you see, the whole point of this is yes, to increase my skills, but also to have fun, right? To ignite the spark of coding, right? That once was there, right? So let's go. And honestly, I'm just having fun coding right at this point, which is a very good thing. Let's start with this and let's see how much we can get done. Okay, let's see if this is even recording. Yes, it is. I just stop this. Majority element. Given array nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume the majority element always exists in the array. So could you solve this n in O1 space? I don't know, man. Okay, so right now I just have to find the majority element inside this. So I mean half of the time, so I can probably do it in n log n, and I can store this because you see, okay, so let's just have, let's say, a set. Okay, so let's say what a hash map in go. Oh well, I think it's just hash map and hash map and go go maps. Yeah. Okay, so I'm starting with this. I make a map which is an int, right? And how do I add to the map? I just say okay, this seems simple enough. Okay. For I equals to 0, I less than the length of nums, and I plus plus, I go. See, the best part about this is now I remember go syntax, and I don't even know if this is correct, but at least I remember something, right? Okay, so yeah, where was I? Yeah, so I just take yeah, so I'm getting a call. Give me a moment. मैं अभी तो मैं हूँ शायद 9 बजे, आप 9 बजे से पहले घर पे आओगे? अच्छा, तो मेरे पास बाइक नहीं है, मतलब शायद मैं देख लेता हूँ सर बाद में। उसको 9 का बोलो, या फिर नहीं बोलो ना, उसको बोलो 9 से 10 के 9 से 11 के दरमियान आ जाएगा कभी। कितने बजे तक होगा? हाँ, इससे अच्छी क्या बात है। हाँ चलो, ओ वापस। Okay, so where was I? Yeah. So first I want to check if, let's see what, oh yeah, so I can't do this because obviously this is in my editor. But guess what? I have an editor, so I can do this stuff like this. M dot clone equals async seal. It's maths dot. pointer. Okay, I think this is just treated like an array. Okay, so there's one thing which I wanted to try out, and I'll try it out right now. Is I want to print, like, let's say I just do this, and I want to print m0, right? And is this what unresolved version? Wait, okay, and I just want to see what happens. 0. What about 3? It, because I think it will give me a 0, right? Okay, perfect. So I can add to a 0 easily, so I can just go nums. No, whatever, what was I doing? Sorry. Yeah, there was, yeah, I was making this, and I just said m, and whatever nums I is, right? Whatever nums I is, I just plus it. The value at nums I just increase the value at nums I, right? I plus it, and okay. Now I go for uh, k and v name range m, right? I mean, that makes sense. I guess k is key and v is variable, and if value, oh, that's actually what I wanted, 𝗗𝗢𝗓𝗓𝗏, or return -1. It's a pretty easy question. I think I'm missing something here. Let's run this. This is linear time. It's just not O of one space, but it is linear time. Okay, that was an easy question. Interesting. Let's just say if there's a way that I can eliminate this hash map and just count, how many counters will I keep? I don't know. Oh, so there's a solutions tab too. That's nice. Cool. This I did. Let's see what is the Boyer-Moore majority vote algorithm. Yeah. So the person is saying that the majority element and majority element frequency. Wait, what's going on again? I understand this, but the Boyer-Moore majority vote algorithm, that's a bit. Initialize first element as the majority element, okay. Reset the majority element and the frequency of the majority element. If majority element double equals to 0, oh, that's actually not. I don't get this case. If majority element frequency double equals to 0, okay, if its frequency. That's an interesting solution. Honestly, that's an interesting solution. If I think about it, it goes in minus, 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 minus. Okay, so if there are like, let's just take a test case, right? So it'll go plus, it will minus, now it becomes 0, so 2 is the majority element, right? And then it will go plus. It will go plus 2, then it will go plus, that was 1, that will minus, minus, it's a 0, and go plus, so 1. What if, just change this? What if the test case is 1, 2, 3, 4, 5, 6, 6, right? Yes, 6, 6. Yeah. So test case, let's just say 1, 2, 3, 4, 5, 6, and 6. Right. Why? Oh, because it's not 2. So it's 1, 2, 3, 4, 5, 6, 7. So at least 4 should be 6, right? This, it will minus 1. Now it's 0, so the majority element is 1. And the majority element is 2. And the majority. Oh, 6 and the majority. Because. Okay, so let's say if what is the worst case that can happen, right? That I've exhausted all my majority elements, right? So 6, 6, 6. So this is 4. Right. So let's just say there are 4 6s which I've exhausted by 4 4s. Right. This has been exhausted. So then there must be another 6. It's intertwined. That it doesn't make any. So this will be this will be this will be. It's too. I mean, I get the intuition behind it. Obviously, it's a bit hard to wrap my head around it, but I do get the intuition behind this. Okay, sure. Let's just see through this. Okay, what does this guy say? Given an integer of size n, find all the elements that appear more than n divided by so more than a third of an array. So honestly, if I want, I can just copy this, right, and modify this a bit and say, okay, I already have this, and if v is greater than nums divided by 3, right, then what I say, okay, then let's just say, yeah, let's just say ants where ants how did you declare a variable where ants which is an int, something like this? Is this a correct way to declare? Not sure. Yeah, that's the correct way to declare. Where ants int, and let's just say ants dot ants equals to append ants with k, right, and return ants, and I run this. Okay, so I guess I'm done with this too. Okay, I think I just want to do the I think I want to do a bit on I want to implement the Moore thing algorithm because that's just a fun algorithm and I like it. But I don't know, I think that just works because the plus minus thing works because, well, let's see the submissions, right? The guy is doing in 𝗗𝗢𝗓. This guy is still doing the 𝗗𝗓𝗓 thing. Yeah, so yeah. So now the guy has three counts. That is true. We can only have two numbers at max with count greater than this. So if I have two counts, okay. So what does this guy do? It says if num equals to num1, okay. So okay. So count 1 plus plus, count 2 plus plus, sure. If if they're equal, if num equals to num1, yeah. So you know what? This is a very ingenious way of solving stuff. It's a very genius way of solving stuff. I really like. Obviously, this is fine, but this this is a very good way of solving things. Should probably try, but I just don't want to right now because well, I have a meeting at 8, so I have like 5 minutes. Now this is an interesting solution problem. So there is a robot on an m by n grid. The robot initially located at the top left corner. The grid 0 0. The robot tries to move to the bottom right corner. Yeah. Grid m minus n. The robot can only move either down or right at any point in time. Down, right, down, right. Okay. Given two integers and return a number of possible unique paths that the robot can take. This is an interesting problem. 1, 2, either go down or right. So 1, 2, this is one path. This is one. I could just brute force this. I'm just saying. I could probably just brute force my way out of this. Right? Have the robot go every possible path by recursively allowing it go either right or left and just adding all the paths where it reaches the finish and boom. I mean, that's a solution, all right. Let's just let's just try to see. I don't think that's a good approach because there should be a way to go down and right, down and right. What should be done here? Down and right, down and right. Then right, 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 right. I think mm, the best way the best way would be to find to brute force it with dynamic programming. So the best way would be programming, yeah. So the best way would be to brute force it with dynamic programming, meaning let's just brute force and store the path. So okay, let's just say, oh, or I could backtrack maybe the A star algorithm, maybe the A star algo, I think it's called the A star. It goes and it goes and it sees, but I don't think so. But the backtracking thing still can apply. So what I'm thinking of is what I am thinking of is brute forcing first, then creating a m by n matrix and storing the outcome from finish to start, right? Yeah, so if I can find like from finish to start, then I know that this path will take this much time, or maybe just and storing the outcome of each tile in the respective row and column, then storing the outcome of each tile in the respective row and column, and then if I encounter that again, I can simply add to that and get the answer. Okay, but the first thing is brute force. So let's brute force. Let's just name it unique path brute force. Yeah, so what is unique path brute force? It's a function that, okay, so it's time for my meeting, so I'll probably stop here and continue on my own. So okay, so today's day, good day, actually very good day, cause two very easy problems that were in hard, lead code medium. I don't know why, they should probably have been in easy, but whatever, right? So I'll do unique paths later, maybe even tomorrow, and it depends on the time. And now off to my meeting. Okay, so catch you guys later. Tada.